For centuries, turning lead into gold was the obsession of alchemists. They believed that through secret formulas or mystical rituals, base metals could be transformed into precious ones. It was a dream that defined early science, and for the most part was dismissed as impossible. But in recent years, that dream came closer to reality than most people realize. At CERN, the world's largest particle physics laboratory, scientists have successfully changed lead into gold. Not in the sense of making jewelry, but at the atomic level, using pure physics. The process didn't happen with bubbling cauldrons or hidden laboratories. It happened at nearly the speed of light inside the Large Hadron Collider, and the way it worked is a modern-day lesson in nuclear physics. Let's break this down. Every atom has a nucleus made of protons and neutrons. The number of protons determines what element it is. Lead, for example, has 82 protons. Gold has 79. So to change lead into gold, you need to remove 3 protons from a lead nucleus. Sounds simple, right? It's not. CERN achieved this during a specific type of experiment called an ultra-peripheral collision. In 2015, during LHC Run 2, CERN began colliding lead ions, not head-on, but near each other. Close enough for their electromagnetic fields to interact, but not physically crash. These near misses created powerful photon exchanges, essentially beams of high-energy light. And when these photons struck a lead nucleus, they could knock out a few protons, sometimes exactly 3. When this happened, the lead nucleus, originally 82 protons, was reduced to 7, and 7 protons is gold, the same gold that sits in your jewelry, coins, or electronics. CERN's ALICE detector was able to observe this transformation with extreme precision. Specifically, it used 0-degree calorimeters, highly sensitive instruments that detect particles traveling directly along the beamline. So did CERN strike it rich? No. The amount of gold created was extremely small, about 29 picograms over the course of several years. That's a millionth of a gram. You could never extract or sell it, and it decayed almost instantly. But that wasn't the point. This wasn't an economic experiment. It was scientific. Creating gold at the atomic level showed just how much control we've gained over matter. Not symbolically, but literally. The experiment gave scientists real data on how nuclei behave under extreme conditions, how photons interact with heavy ions, and how beam stability can be affected at the subatomic level. It also served as a milestone for our understanding of electromagnetic dissociation, a process where 2 heavy nuclei interact via their fields rather than by direct contact. This kind of research has implications for everything from radiation shielding to deep space particle physics. So what does this mean for the age-old quest of alchemy? It means the ancient dream was, in one sense, always theoretically possible. It just took us thousands of years, the world's largest particle accelerator, and the most advanced detectors on the planet to do it. Will we ever be able to convert metals into gold on a practical scale? Probably not. The energy cost to remove protons, control decay, and stabilize the product far outweighs any profit. But the symbolism remains powerful. We've moved from myth to measurable transformation, and in doing so, we've turned the story of alchemy into a real scientific event. This is science broken down. If you want more science demystified and explained like this, keep watching. We'll keep turning complex reality into understandable knowledge, one video at a time.